In this slide, we have an example 12.3 for confidence interval calculations. And we will determine the mean and the 95% confidence interval for the data given below. This data that we used in the previous examples, 12.1 and 12.2. Perform the three estimates based on the first 8, the first 16, and first 24 measurements. We have 24 measurements here. Let's use initially the first 8 measurements to calculate the confidence interval. Basically, for the confidence interval, we have the formulations of, maybe we can write them. Let me write them in red to see. L is equivalent to the sample mean minus the sample standard deviation divided by the number of samples root square and the t distribution, because we have limited data, alpha divided by 2 and n minus 1. And upper bound is the same, but with only plus sign, sy divided by root square n, t alpha divided by 2 and n minus 1. So we will need to calculate these parameters to be able to calculate these L and U. Let's calculate the mean first. And initially we will use for 8 data. A for n equals 8. You know that the mean is just the summation of the data divided by n. The summation of data is for the first 8 here. We can sum these. When you sum them, it is 52.72. Sorry, let's write it in black. 52.72 divided by 8 number of data, and the mean is 6.59. And let's calculate SY as well. And to calculate SY, we need, if you remember, let me show the formulation first for SY. If you remember, it was maybe we can write the variance formulation. If you remember, it was the total yi square minus total yi square divided by n divided by n minus 1. So when we take the root square of this, it becomes again the standard deviation. So we know these values. Of course, for this we need to have the square of all of these, then sum them, and the result becomes from here 347,4814 minus the total summation here is this actually, so 52.72 and its square divided by n is 8, and divided by n minus 1, meaning 7, and the root square of this, and the result from here is 0.089921. So we obtain this one and this one. So we need the t distribution value as well. For the t distribution, we will simply find t. Alpha is not for 95%. Alpha is 0.05, so 0.05 divided by 2, and n minus 1 is 8 minus 1, 7 actually. So t 0.025 and 7. And the result for this is 2.364623 from t distribution table. We will show this t distribution table and also a MATLAB code for it in the next chapter while using it for the regression. Here I will just keep it short to show that you can just find this, or you can Google it and find the t-distribution table, Google this, then get this result from that table. Actually, you can see from there. So when we plug these into these equations at the top for L, basically we will calculate 6.59 minus SY is 0.089921 divided by root 8 and 2.364623. Then L is equivalent to 6.5148. And for U, it is the same, but just the summation 9921 root square 8 times 2.364623, and then U is 6.6652. You can see that the mean should be between these. And so we can say 6.5148, the true mean is between these, 6.6652, with 95% confidence, we can say, or with 95% probability, the mean falls, the true mean falls between these values. And if you remember, the true mean actually about like 6.6, so for this, it actually is between this. So we did this for n equals 2. We can do the same for 16 and 24. Just apply the same data, change this with for 16 15, for 24 it's 23, and get the new data from here. Also these will be new for 16 and 24. Then calculate these L and U again to have these confidence interval values. I will not do the detailed calculations, but I will show a table that compares all of these data for n equals 8, 16, and 24 in the next slide. In this slide, we have this table showing all the calculated statistics for 8, 16, and 24 data. So this 8, we did this in the previous slide and obtained these values. If you use 16, then you can see that mean is decreased a little, standard deviation is increased a little, and this t is also changed. And you can see the range of L and U for the true mean is actually reduced. So this is increasing, and this reduced. So the range decreased here. Similarly, for 24 data, so this increased a little, this increased a little, this also changed, and we can see L and U decreased also. The range between these decreased. So this increased and this decreased. So this increased as well. So it's not important that increase or decrease, but the importance is the range, and you can see it here as well. So these are the lower and upper bounds for the true mean, and we expect that with the increase of the data, the range will get narrower. And you can see here that the sample mean is here, and this is the range, lower and upper bound. And when it is 16, these values are here, so it decreased. As you can see, this is larger, this is lower. Here this also decreased. Of course this changed a little to the right, but it's not important. The importance is that the range decreased. And basically the true mean actually is between somewhere here. So we can see that for all we have the true mean here, but with the increase of data, our confidence interval is getting narrower, which is expected. When we have enough number of data, so this range will be 0, and it will just show us the mean value actually. So it can be maybe for 1,000 samples, for instance. So the confidence interval becomes narrower as the number of samples increases. And therefore, the more measurements we take, our estimate of the true value becomes more refined. That's the basic idea. And we were able to obtain the lower and upper bounds for mean for a certain significance level, which was 0.05 here. That defines the 95% probability or confidence. We completed chapter 12 here. This chapter was about the statistical measurements or parameters, calculation of them, simple statistics. which are useful for the regression or curve fitting. So you can read some information about this in your book in the section of PT5. And after this, we will be going to the regression side in chapter 13.